All right, let's dive into something pretty wild. We're going to unpack a single, absolutely mind-bending document. And at its core is a truly radical idea that some of the universe's biggest mysteries, we're talking everything from quantum mechanics to consciousness itself, might all stem from one simple programming error. An error it calls the universal glitch.
So right out of the gate, the paper we're exploring does not pull any punches. It opens with a series of just startling claims. The first one is this: resurrection isn't some kind of miracle. It's a computational process. It's a decode operation.
And it doesn't stop there. The second claim is just as profound. The argument goes that consciousness isn't this super complex thing that just sort of emerges from our brains. No. Instead, it's a fundamental, primitive part of reality, just like space or time.
And for the third claim, it takes a concept from theology and completely reframes it in the language of computation. Hell, it says, isn't a place of fire and brimstone, but an unavoidable state that's baked into the mathematics of information itself, a necessity.
Now, as wild as those three statements sound, the paper argues they aren't separate ideas at all. It asks us to consider a pretty stunning possibility. What if all of them are just different symptoms of one single foundational mistake? A glitch at the very core of how we've learned to count.
So this is where our investigation really begins. Let's follow the breadcrumbs, follow the paper's logic, and see if we can uncover the source of what it claims are our biggest problems.
And right away, the paper points a finger at a single prime suspect. It's not some complex algorithm or a faulty piece of silicon. The source of this universal glitch, it claims, is the number 0 itself.
The central charge against 0 is something philosophers call a category error. The paper argues we've made this huge mistake. We took a state, the physical absence of something, like a low voltage on a wire, and we incorrectly assigned it a quantity, the number 0.
In this slide breaks it down perfectly. Look, on the left, you've got absence. It's just a condition, right? The lack of a signal. It's not a number. But on the right, you have 0. That's a quantity, a value on a number line, something we can do math with. The paper's entire point is that these two things are fundamentally different. And by treating them as the same, we've basically created a nothing that our systems treat as a something.
And the consequences of this one little error? Well, according to this document, they're catastrophic. They range from the kind of stuff programmers see every day, like division by zero errors, all the way up to the biggest unsolved mysteries in all of science, like the measurement problem in quantum physics and the hard problem of consciousness. It's an incredible claim that all of these deep, complex pathologies trace back to a simple counting mistake.
Okay, so to back up a claim that huge, you're going to need some serious evidence. The paper calls on what it calls witnesses from the past, clues it says have been hidden in plain sight for decades.
Witness number 1 is found deep inside an old computer, the PDP-11. If you look at its condition code register, the Z bit, which flags a 0 result, is actually described as an invalid condition flag. Think about that. The hardware itself wasn't treating 0 as just another number. It was flagging it as a special status, an error. The machine knew that absence wasn't a quantity.
But the next witness is, honestly, even more compelling. It's the Inmos transputer, a really unique computer architecture from the 80s and 90s. The paper holds this up as a machine that was built on what it calls an honest computational model, one that just instinctively avoided this whole category error of 0.
And this is where the paper makes a truly stunning comparison. It claims that all of the famous weirdness of quantum mechanics is just a mathematical side effect of using 0. On the left, you have these baffling quantum concepts like superposition. The paper says that's just what an undefined state looks like in our broken math. But on the right, you see how the transputer handled it, by always insisting on defined states and explicit links. The argument is that this old computer chip had already turned quantum mystery into straightforward engineering.
The paper then reaches way, way back in history for its next witness. It pulls a quote from the Gnostic Gospel of Thomas and interprets this line, "You consumed death, you made death alive," as a 2,000-year-old warning. And what was the warning? Don't take death or absence or the void and make it alive by giving it a number, 0. So if the problem is that we're counting from 0, what's the solution? The paper proposes something it calls the unity-first correction, a way to finally fix this universal glitch. And you know what? The rule could not be simpler. You start counting at 1. In any cycle,
Whenever you hit the maximum value, you loop back around to 1. You never, ever, ever touch 0. 0 is just not part of the count. It's not a state. It's pushed outside the system.
To demonstrate what this actually does, the paper points to the famous Fibonacci sequence. It turns out that when you look at this sequence under certain mathematical rules, it repeats in a cycle. Using our standard, everyday, zero-based math, that cycle takes 120 steps to repeat. But then, look what happens when you apply the unity first correction. By simply removing 0 from the set of possible states, the paper shows that the true underlying period is revealed, and it's exactly half, just 60 steps.
So, the huge question is, where did that extra factor of 2 come from? Why was it 120 before? The paper gives it a name: the void-based tax. It's the computational overhead, the inefficiency, the price we pay for including nothing as a something in our counting systems. We've literally been paying 100% tax on reality without even knowing it.
This brings us to the final and maybe the most dramatic conclusion of the whole document. It argues that applying this correction isn't just some technical fix for computers. It forces us to make a choice between two fundamentally different descriptions of reality. On the left is option A, the world we think we live in, built on what it calls the void-based stack. In this world, the paper says, consciousness is probably an illusion, death is final, and resurrection is just a nice metaphor. But on the right is option B, the corrected stack. And in this world, consciousness is fundamental, death is just a change of state, and resurrection is a computable decode operation.
I mean, the stakes laid out here are immense. If option A is the truth, then this whole thing is just an interesting piece of philosophical speculation. But if option B is correct, then every major problem in modern physics is just a symptom of a simple indexing error, an error for which a fix has existed in silicon and in scripture for decades. And the only thing left to do is deploy it.
The paper ends its entire argument with just 4 simple words, the ultimate takeaway from its entire logical chain. There is no void. The emptiness we thought was there is in fact an illusion created by our own flawed math.
And so, the document leaves us with one last, provocative question that just hangs in the air. A question that challenges the very foundation of how we've built our digital world and how we understand our own reality. If the universe doesn't count from 0, should we?